Hello everybody, we're getting ready to do lesson 5.5, Parabola and its equations for SAT Math Level 1 prep. There's 88 points in this lesson today about the parabola and its equations. And there's 56 points to taking notes for it, and then 88 points for the tune-up that comes after this lesson today. Okay, the graph of the quadratic function y equals ax squared plus bx plus c is a u-shaped curve called a parabola with c as its y-intercept. Here is your y-intercept here. When x equals 0, y would be the c here, its y-intercept. If the constant a is greater than 0, the parabola opens up. So if a is positive, it opens up, and the turning point or vertex of the parabola is the lowest point on the curve, or the minimum. This would be the minimum of this parabola if a is greater than 0. A is greater than 0. If the constant a is less than 0 or negative, then your parabola will go like this. Parabola opens down, and the vertex of the parabola is the highest point or the max. This would be your maximum up here of your parabola if a is negative. The vertex of a parabola, a line can be drawn through a parabola that divides it into two mirror image parts. Of the two image parts, the line of symmetry intersects the parabola at its vertex. The vertex is either the highest or the lowest. Here in this case it's a minimum or the lowest here, line of symmetry. A is greater than 0 or positive for this parabola. With a greater than 0, that's what your parabola will look like. This is an example here. Here is your line of symmetry here. If a is negative, the parabola opens down. This is what your parabola looks like if a is negative. And the vertex would be the highest or the max. This would be your max here if a is negative. That would be what your parabola would look like. And then here's a line of symmetry here for that. A less than 0. A would be negative. The equation of a line of symmetry of a parabola equation is given in standard form. You can use the formula x equals negative b over 2a to find an equation of the line of symmetry, which also gives the x-coordinate of the vertex. So this is your x-coordinate of the vertex here, negative b being negative b over 2a, 2 times a, and then that will give you your x-coordinate of the line of symmetry. If y equals negative 2x squared minus 12x plus 3, then the equation of the line of symmetry is negative b over 2a, or negative 12 over 2 times 2, the negative of that, which would be 3. Since the x-coordinate of the vertex is 3, you can find the y-coordinate of the vertex by plugging your 3 back into the original quadratic here, and your y would be negative 15. So your vertex would be when x equals 3, y equals negative 15. And since this is positive, it would be like this. The vertex is at 3, negative 15. Okay, so here is your parabola here with a positive a is pointed up, and then your line of symmetry is here at 5, 2. This is the vertex right here at 5, 2. So your line of symmetry would be x equals 5. This is your line of symmetry here, x equals 5. And then on each side here, say for example, when y equals 6, x equals 3, and when y equals 6, x equals 7. So you're moving to the left 2 and you're moving to the right 2, and still with a y coordinate of 6, and this is at a right angle here, so that's pretty good diagram. The point 36 is on the parabola 2 units from the line of symmetry. The matching point on the parabola is 7, 6, which lies on the opposite side of the line of symmetry. Okay, so the vertex form of parabola, y equals a times x minus h squared plus k. The vertex form, which equals this, where h and k are the coordinates of the vertex. So if y equals 3 times x minus 4 squared plus 7, the parabola opens up because this is positive here. And this is positive, so it would have to. If this is negative, it would open down, but it opens up, and the vertex will be at 4, 7. So here is x, and here is y. I mean, it would be the negative of negative 4, which is 4, and then 7. X minus h squared. So the negative h here, in this case, would be positive 4. So 4, 7 would be your vertex, which is a minimum, because it opens up like that. So 4, 7 would be a minimum. Line of symmetry would be x equals 4. Here is your x coordinate, so x equals 4 would be your line of symmetry. Okay, rewriting parabola equations. The SAT may ask you to rewrite the equation of a parabola in order to reveal certain information about it. If y equals x squared minus 6x plus 8 as y equals x minus 2, x minus 4, its x-intercepts appear as constants, which would be here. These you're solving for 0. Those will be your x-intercepts. And the min or maximum value appears as a constant as well in this situation here. So in this situation here, y equals x squared minus 2x plus 8 is written in equivalent form x minus 1 squared plus 7. So in this situation, the minimum value of the function will be 7 here, because when x equals 1, y would equal 7. That would be the minimum. That would be the minimum value of that, because it opens up. And when x equals 1, y would equal 7. That would be the minimum value of the parabola. The graph of the function f of x equals negative 1/2 times x plus 4, x plus 8 in the xy plane is a parabola. Which of the following is the equivalent form of the function f in which the maximum value of the function appears as a constant? So here are our choices here for a minimum value of this, which appears in this form here. Which one of these would reveal the minimum value of this as a minimum? Well, the max or min value of a quadratic function is the y-coordinate of the vertex of its graph, which appears as a constant k. So in the vertex form of the equation, a times x minus h squared plus k. So where k is a minimum is what we're looking for. So using FOIL, multiply the binomial factors of f of x, which gives this situation here, negative 1/2 times this trinomial here. And then when we multiply through, we end up with this situation right here, negative 1/2 times x squared plus 12x minus 16. So the negative 16, to change to the vertex form of the parabola equation by completing a square, so this becomes, see, plus 12 over 2 squared would be 6. So that'd be 36 times a negative 1/2. That'll be a negative as well, so it'll be 18. So we would add 18 to both sides here. So this is attained by adding negative 1/2 times 36. So what we have is negative 1/2 times x plus 6 squared plus 2, which by comparing with the first one, and negative 1/2 times x plus 6 squared plus 2 to f of x equals a times x minus h squared plus k. Our vertex here would be a would be negative 1/2. This would be our a, and then our h would be negative 6. And k would equal 2 in this situation here. So in that situation, since a is less than 0, vertex of the parabola is a max, and the value of f would be 2. So it would be this here. It would not be this. This would almost be your intuitive because you have a 16 here. But when you go back through and you put it into vertex form by completing the square, starting from that method there, you get negative 1/2 times this quantity here plus 2 when you add your b squared over 2. The equation gives the profit in dollars y. A coat manufacturer earns each day where x is the number of coats sold. So this would be the number of coats sold. Y is our dollar amount. What is the maximum profit he earns in dollars? So we got to find the max of this parabola. It's negative, so the parabola is going to go like this. So the vertex of the parabola will be the highest point on the graph because we have a negative a here. So we need to determine where the vertex is of this parabola. So to do that, this parabola here, the coat manufacturer must sell 60 coats each day to earn a max profit for that day. So we have this situation here, negative b over 2a. We have the negative of 120 over negative 2, which is 60. So we plug that back in. We plug that back into here. It corresponds to the y-coordinate of the vertex. Substitute the 60 back into the original, and we get negative 60 squared plus 120 times 60 minus 2. So that would equal 1,600. So to maximize the profit for that day, it would be $1,600. It would be his max profit for that day. That would be your y-coordinate for 60 coats. Stacy has 30 meters of fencing that she wishes to use to enclose a rectangular garden. If all of the fencing is used, what is the maximum area of the garden that can be enclosed? So she has 30 meters of fencing that she wants to use. If x represents the length of the enclosed rectangular garden, and W represents its width, then all 30 meters of fencing are used when 2x plus 2y equals 30. She has 30 meters of fencing that she wishes to enclose a rectangular garden. So simplifying makes it x plus w equals 15. So knowing that w would equal 15 minus x, if a of x represents the area of the enclosed rectangle as a function of x, then a of x equals xw equals x times 15 minus x, which equals negative x squared plus 15x. Now this is going to give us a max. Find the x coordinate of the vertex. So we have our b and we have our a here. We can find. So finding the x coordinate of the vertex, negative b over 2a, be 15, the negative of 15 over 2 minus 2 times negative 1, The max value of a of x occurs at x equals 7.5. So if we plug that back into the original, we'll get this number here, 56.25 squared meters. That would be the maximum area that she can enclose by 30 meters of fencing. Okay, some parabola facts here. If y equals ax squared plus bx plus c, an equation of the line of symmetry is negative b over 2a for our x coordinate. If f of x equals a times x minus h squared plus k, the vertex is hk, and an equation of the line of symmetry is x equals h. This is our x equals h right here. This is our line of symmetry for this parabola here. Negative b over 2a equals h. Here is our h, or x coordinate of this line here. If a is greater than 0, k is the minimum of the function, and if a is less than 0, k is the max. So this one opens up, so this is a min here. This k would be a min. The line of symmetry is a perpendicular bisector of any horizontal segment whose endpoints are on the parabola. So h equals p plus q over 2. That would be another way of putting it. So this would be p and then q here. We add them, and then the average distance between that would also be your line of symmetry. That's another way of expressing your line of symmetry. Would be the average distance of this, I don't know what you call it, like a perpendicular bisector of the line of symmetry. Okay, here's your parabola up here, standard form. This is vertex form, and then this is standard form here. And h equals r plus t over t. So this is your r and this is your t. Just again the same thing. You're taking the average of this distance here and dividing it in half, and here is your line of symmetry there. Modeling projectile motion. A projectile motion that is under the influence of gravity, as when a ball is tossed, has a parabola-shaped flight path in which the x-coordinate at each point on the curve represents how much time has elapsed after the object was launched. The coordinate gives the height of the object, so the y-coordinate gives the height of the object at the instant of time. The vertex of the parabola corresponds to the point at which the object reaches its maximum height. So the vertex of this parabola that models a projectile motion, the max of that is the vertex of a parabola that models this. So let's get so the function represents the height and feet of a ball here in this situation. Here's our quadratic. A ball reaches t seconds. So this is our time here after it is tossed in the air from ground level. So what is the maximum height of the ball with this projectile motion here, with this parabola? So the maximum height of the ball corresponds to the y-coordinate of the vertex. So we need to find the y-coordinate of that. The x-coordinate, negative b over 2a, is 4.5. When we plug in our values here, the x-coordinate of the vertex would be 4.5. Now we plug that back in here into our original. The y-coordinate would be h of 4.5 equals 144 times 4.5. Plug it in here. Minus 16 times 4.5 squared. That gives us a y-coordinate here of 304. So the maximum height will be 324 feet of that. After how many seconds will the ball hit the ground before rebounding? So now when the ball hits the ground, h of t would equal 0. So for 144t minus 16t squared equals 0. So now we factor out a 4t. 4t equals 0, or 36 minus 4t equals 0. So t equals 0. Negative 4t equals negative 36. So t in this situation here will equal 9 seconds. So the solution t equals 0 represents the instant of time the ball is tossed at 0 time. The solution t equals 9 seconds is how much time it takes for the ball to fall back to the ground. Solving nonlinear systems of equation. We kind of change gears here a little bit. A linear quadratic system can be solved algebraically by solving a first degree equation for either variable and then substituting for that variable in the second degree equation. To solve the system here of these two equations algebraically, solve the linear equation for y. That gives you y equals 1 minus x over here, y equals 1 minus x. And then eliminate y in the quadratic by replacing it with 1 minus x. So the result would be 1 minus x equals negative x squared plus 4x minus 3. X squared minus 5x plus 4 equals 0. Solve x squared minus 4x minus 5x plus 4 equals 0 by factoring. X minus 1, x minus 4 would equal 0. So that would be x minus 1 equals 0 or x minus 4 equals 0. So x equals 1 or x equals 4. So find the corresponding values of y by substituting each solution for x in the linear equation. If x equals 1, then 1 plus y equals 1, y would equal 0. So 1, 0 is the solution. If x equals 4, then 4 plus y equals 1, y would equal negative 3. So 4, negative 3 would be another solution. That would be the way that you would solve that. A system of a linear and a quadratic. When a nonlinear system of equations is graphed in the xy plane, the points of intersection common to all of the equations, if any, represent the solutions to the system of equations. So we have this situation here where we have, I guess, a circle or an ellipse, and then we have a parabola, and then we have a line here. A system of three equations whose graphs in the xy plane are a line, a circle, and a parabola are shown. Okay, so this is a circle. How many solutions does the system have? So 1, 2, 3, or 1, 2, or 4. So the solution to the system of equations is a common point or points at which the line, circle, and parabola all intersect. So where they all intersect. Where do they all intersect? It looks like maybe here, maybe there. That would be the one here. So when there's one solution for this system here. And that is 5.5. That is the lecture version of 5.5. The tune-ups is coming up next, so stay tuned for that. Any questions or materials or tutoring, email me here. Thank you very much.